Okay, so if we're going to try to figure out the 20/20th term of this thing, we need to first recognize that it's an arithmetic sequence, and we can work with the fact that we know the fifth and ninth term. I noticed that whatever the common difference is, that we're going to have to use that twice. No, I'm sorry, 4 times to get from the fifth to the ninth. Let's make a quick table. The fifth has -71. 6, 7, 8, then 9. And at the ninth term, we're at -55. And so let's see if we can figure out what is the common difference in this particular case. 71 to 55 over a difference of 4. Looks like that we are getting 4 is the difference. So once we know that, then we can work with our general rule. A of n equals 4n minus 1 plus some sort of starting amount, right? And we still don't know what that is, but we can go back in the table and imagine going back to 1. That's going back 4 steps again. 4 times 4 is 16. 16 down from 71 means that at the first term, it must have been -87. So -87, there we go, we got our rule. So 20th term, plug that in there, and A of 20/20 is now just plug and chug. For a geometric one, we can use a lot of the same thinking, but we're asked in this case to find the second term. I know that the general rule A of n equals the A of 1, the first term, times the ratio, common ratio to the n minus 1 power, but I really don't know any of that here. I do know the fifth and seventh terms are off by 2 steps, so that's pretty sweet. If I kind of worked with that, I could say 567 times something twice should equal 5103, and that'll give me my common ratio. So let's do a little math on that. 5103 divided by 567. Give me a second here. 5103 divided by 567 is 9. So something squared equals 9. Okay, we got 3 as the common ratio. So we can try to figure out what the first one is, but that's not really the point. We want to figure out what the second term is. So if we're going to do that, we can figure out, well, how many terms do we need to get from the fifth term to the second term? Well, 5 to 2 is 3 steps. And so the second term must be just 3 multiplications down from this number, 567. So 567 divided by 3 cubed be a 21. Hooray!